Hello everyone, this is Harish Chodapurkar and I'm going to talk about AutoML for time series problems. So, as my friend Satya spoke about the uh, details of AutoML and the evolution, so now I'm going to talk about more specifically on how AutoML is applied on the time series problems. So, if we broadly classify the AutoML, we can take a look at data preparation, feature engineering or feature selection, model selection, and then finally the forecasting using the best model. So what happens inside the data preparation is a standard one like normalization, imputations of nulls, zeros, outlier detection, balancing the data, so on and so forth. And then inside the feature selections, how the features are selected using cross validations or more techniques, my friend Al is going to speak about. Then I'm going to speak more specifically on the model selection, how the models are selected, how the model parameters are tuned, and what happens inside an AutoML algorithm. So, and finally the forecasting using the best model. So, the next thing. So when we talk about the time series algorithms, there are we can broadly classify these algorithms into regression and the deep neural network time series algorithms. So inside the regression algorithms, we have a lot of variations, starting from the auto-regression, simple moving averages, and to the seasonal auto-regressive, vector auto-regression, and then finally the Holt-Winter exponential smoothing. So in combination, these are the most standard, and this is how kind of the time series algorithms have evolved in terms of the regression ones. And then with the neural networks one, with the neural network, we have the recurrent neural network variation, which is the LSTM, and modified one, which is the gated recurrent units, which is the GRU, and also we have the CNN LSTMs, and like there are many variations of these. So on top of this, we have the state of the art time series algorithms, which is the Prophet, developed by the Facebook, and the Gluon TS, developed by Amazon, and also there is one more which is developed by Microsoft, which is the Forecast TCM. So let's quickly. So I'm going to talk about three specific algorithms here. One is the AtsPy, sorry, not three, only two. AtsPy and the AutoTS, and this is one more which is the Azure AutoML, but that's gonna we'll park it aside and talk about it some other day. So let's start about the AtsPy. So what is AtsPy? AtsPy is an open source offering for the automated time series modeling. So why AtsPy? So the quick quick points are already written here. So how simply we can invoke this method is the just automated ML, install the package and then call this method, pass your data set. That's all. What happens inside, forget it. It does all the stuff for you. So how it does and what it does. So just the highlights of AtsPy. It uses the structural and the model errors, and does the feature selection by applying the light gradient boost and also the TS infused features. And it also works on the seasonal. It definitely works on the seasonal data using the singular spectrum and the periodograms. And it also combines the predictions using the ensembling with complex or the simple one, and so that you can get the best model out of the ones which are being used. And also it allows the usage of the GPU. And when we talk about the progress, so it is still limited with the univariate forecasting, and that's the only limitation right now, but still in progress. So so when we get into more specifics about AtsPy, um, so if we can see these three lines of code here, how do we invoke? Once we pip install the AtsPy, we can invoke it just this way, and then you can specify what models you want to select, And there are, as I mentioned earlier, you can try all these models like Arima, Gluon TS, Prophet, so on and so forth. And so all you need to do is invoke the model, pass your data set, specify the list of models, and then do the forecast length, which actually tells you like how much forecast length you are gonna try your model. So before we come here, the AtsPy, what it does is it keeps the futuristic forecast. Say if your data set is of 12 months, you park 1 month aside or maybe 3 months aside for your testing. It does an internal split, and it uses only the first 9 months for training the data, and then the next 3 months for testing the data. This is for the early run, and there are like a lot of steps involved inside the AtsPy, which I can definitely go. Um, so so let's go over more details about this stuff. So the most important one here would be the ensemble. So this ensemble so let's look at it here. So when you look at the ensemble models here, it's going to tell what models you chose, and how's the performance of each of those. And also when you combine that, you can actually look at how the trend is going on, so how the actual data is, and then how the models are performing. So this is pretty cool, and we are not doing anything. This is everything is taken care inside the model. And so these are the like quite good features of AtsPy, and still in progress, I think. Let's move on to the AutoTS. So let's quickly talk about the AutoTS. So I spoke about the AtsPy, and this is another package, AutoTS, which is like a little more advanced and sophisticated, and which can handle univariate as well as the multivariate time series problems. So these are the top features. Why should we, of the AutoTS. And what it does is like it does the it preps the data with the optimal with the and handles the data optimally with the non-imputation, outlier removal, and normalization, and so on and so forth. Then it also tries the various assortment of various models, and assortment of various model hyperparameters, which and gets the best model out of those. So like if you just go over this, like point and probabilistic forecasts, multiple cross validation options for feature engineering, automatic ensembling of best models, subsetting and weighing to improve search on multivariate series. So all this kind of add up, shows that like this is a more tuned and advanced algorithm in the auto in the time series AutoML. So how does it really do? So it begins with like taking the long data and converting it to a wide data, and it does an initial split to run the model, and then random models are chosen, and then the model, so it also does the in the pre-transformation, the data prep stuff. It also does the fill NA, the outlier removal, and all, so on and so forth stuff. And finally, when the top models are when it collects the top models, it collects it by the combination of specific metrics, which we are going to talk about, and then they are recombined with random mutations of n generations. So the number of generations is like how many different models you want to try, how many trials you want to do. So this is kind of a high level process. So and finally it does, once we have all these best models, it does the ensembling of models to get the best results, best forecasts. And also it doesn't really just do the split once. It does the split on the second time, where it reassesses if the model chosen is really performing well. So this is a very simple example of the auto TS. So these are the like the parameters what you're supposed to choose, and the ensemble if we select all the ensemble, that's going to take more time, but it's going to give you best results. So the max generations is how many times you want to run the various models, and yeah, so you can so you here the time series, the advantage of this model is like it can accept the various lengths in the time series, the hourly, daily, weekly, or yearly, and also it allows you to, like, it automatically converts the long into the wide. And so the next thing is like how does the auto TS weighs the different models. So it again depends on what. So it allows you to give the weightage. Say if you want to choose by the RMSC weightage, so the higher the number, it the more the weightage. So the SMAP weighting, the RMSC is 5 and the SMAP is 10. So across the models it takes the SMAP as the more important. If you set something as 0, or or minimal weightage, it nearly 0 means it definitely ignores that metric, and 1 is the least priority one. So based on this, a score is developed, and based on the best score of each model, it's gonna bring up that it's gonna do the forecast based on the best model. So yeah, so these are the top features of the auto TS and the AtsPy. So I can definitely go in more details. So you can just go over the web links which I have provided at the end of the topic. Um, you can go over all these web links, the auto TS, AtsPy, Azure ML, and more on the time series and auto ML. So um, I think I hope I have tried to cover as much as I could, and the feature engineering and feature selection, and also about the AutoML were very nicely detailed out by my friend Satya and Al. Thank you very much uh, for watching this. Um, Thank you.